So we have learned about geometric sequences. We already knew about exponential functions. So now let's look at an example that will have us connect your geometric sequences and your exponential functions. So example 4, connect geometric sequences and exponential functions. Oh, I just said that. All right, here we go. The number of subscribers to a blog doubles each week. How can the trend in subscribers be modeled? So because the number of subscribers double each week, this can be modeled with an exponential function. So to model it with an exponential function, just a reminder what that looks like. F of x equals a times b raised to the x power. A is the initial amount. So in this example, the initial amount is equal to, let's see, over here we can see 5. And the thing that we want to keep in mind is the initial amount, because we're talking about number of weeks, right? Every week, the number of subscribers doubles. So the initial amount happens at week 0. So we want to keep that in mind. That's kind of an important distinction between exponential and geometric. All right, and then our b value is our common ratio, which is 2 because we double each week. So our exponential model, f of x equals initial amount 5 times your common ratio 2 raised to the x power. And this is where x equals the number of weeks since the blog started. And then we just want to keep in mind that it started at week 0. Okay, so there is our exponential function. We also can write this as a geometric function. Because the number of subscribers doubles each week, that's multiplying by 2 to get the next week, multiply by 2 to get the subscribers the next week, and so on and so forth. This would be a geometric sequence if we wrote out the sequence. So to write a geometric sequence, we'll just use the explicit formula, a sub n equals a sub 1 times your common ratio raised to the n minus 1 power. So a sub n equals, our first term is the number of subscribers first week, so that's 5. The common ratio is, well, we said it was 2 when we were talking about the exponential, because we are doubling every week, and this is raised to the n minus 1 power. So there is a geometric sequence. So you can write an exponential model or geometric sequence model. In this case, we did explicit for that. So how many subscribers will there be in week 9 if the initial number of subscribers is 10? So let's look at how we would answer this question 2 different ways. First, what if we wanted to use our geometric formula? Well, we have to change our geometric formula a little bit. A sub n equals, they said the initial number of subscribers is now 10, but it is still doubling raised to the n minus 1 power. So to get how many subscribers there will be in week 9, we're going to find a sub 9. So 10 times 2 to the 9 minus 1 power, which is 10 times 2 to the 8th. And then we grab our calculator and we make sure we use parentheses. We get 2,568 subscribers. All right, what if we wanted to use our exponential model? So our exponential model would be f of x equals, what's the initial number of subscribers? 10, and we are doubling each week, and we're going to raise that to the x power. Now here's where it just gets a little bit tricky. If we're going to use an exponential model, we have to remember that the initial number of subscribers happens at week 0. So if they're asking us to find how many subscribers there will be in week 9, week 9 is actually week 8, or we will use an 8 for x, because we actually started at 0. So 0 is our first initial amount. So what we are going to do is find f of 8. We have 10 times 2 raised to the 8th power. And then we notice, well, that's what that was over there. So we are going to get the same answer, 2,568 subscribers. So it doesn't matter. Well, you can find an answer to a question like this with a geometric model or an exponential model. But just know that slight difference where if you're going to use exponential, the initial amount happens at week 0. That's a very important distinction we have to make. But essentially, they are modeling the same situation.